혼자 없어요. Hi, I'm Yongcheol Kim. I'm a field hydrogeologist working for Korea Institute of Geoscience and Mineral Resources. This morning, I fly down this beautiful Jeju Island to show you this managed aquifer recharge system. Today, I'm going to go down the stream and go down the bottom of the reservoir, and also we'll look at carefully the recharge system. And through this virtual field trip, I hope you come to know the hydrogeological, meteorological characteristics of Jeju Island. And also, I hope you come to know why and how we built this system in 2010. I came down to the bottom of the reservoir. Behind me, you can see the gate, which is divided the Hancheon stream and the reservoir. After the heavy rain, when there is running water through the Hancheon reservoir, they open the gate and then the water flows into this reservoir. And the water can infiltrate through the bottom of this reservoir, which is kind of artificial recharge or managed aquifer recharge. So managed aquifer recharge is kind of water banking. So in the managed aquifer recharge, you can use rainwater and stormwater and reclaimed water from the wastewater treatment plant or desalinized water from the coastal area. You can use those kind of water as recharge sources. And to inject those water to the aquifer, you can use this kind of infiltration basin, or you can use the injection well. So after the injection or infiltrate those kind of the water, and it's stored to the aquifer, and then you can use those water after later when you need the water, or you can use at other places. So this whole system you can call managed aquifer recharge. Okay, now I'm showing you how to recharge the water. Come here. See, the water disappears so fast, isn't it? Because the soil in Jeju Island has very permeable properties. So that's why the rainwater infiltrates well in this Jeju Island. I come down the Hancheon stream. As you can see, this is dry stream. So normally the stream in Jeju Island is dry like this. Only they has a running water after the heavy rain, more than 80 millimeters a day or 50 millimeters a day. It depends on the previous rain events, but we're going to use the running water through this stream for the artificial recharge sources. I'm going to explain the history of Jeju Island and the meteorological property of Jeju Island using this sense. Come here, I will show you. Jeju volcanic island started to made about 2 million years ago. There was ocean sediments like the sediment in the Yellow Sea here, and so there was volcanic eruptions and opponent at the time. So this kind of volcanic eruption made a small mountains, and the ocean water weathered this, and there is another volcanic eruptions, and repeated volcanic eruption make the island goes up over the ocean. And after more than hundreds volcanic eruption during the last 2 million years, they made Jeju Island shape like this. So at the very center of the island, there is a Mount Haller, which is the height is almost 2,000 meters, and the clouds comes from the west. So the west part of this island has low precipitation, and the clouds goes over the Mount Haller and has more water and pour the rain more at the eastern part of the island. So eastern part of the island has more precipitation, and also across the lower area across the island has a lower precipitation, and to the mountain and high elevation area there is a more heavy precipitation, more than sometimes 3,000 millimeters, and at the coast about 1,200, 1,300 millimeters a year. So, but this kind of the precipitation has the main source of this island. So among those of precipitation, about 35% of the water transpirate to the air, and about 40 to 45% of the rain infiltrate to the aquifer, and about 20 to 25 of the rain come to the stream and running through the stream and discharge to the ocean. But about 12, 13 a day a year, they has the running water, and the other times of the time year they has no running water. But the amount of the stream water is enough to recharge for the future for future use. So that's why we made the artificial recharge, made the aquifer recharge system here. Originally, this reservoir made for reducing the flood risk. In 2007, there was a Typhoon Nari. The Typhoon Nari bring a heavy rain in Jeju Island. So because of the heavy rain, there was a flood disaster at the downstream of the Jeju city. So after that, the local government decided to build this flood mitigation reservoir. At the same time, the research team, including me, tried to find out the diversion system which diverts the stream water to the reservoir to inject to the aquifer. So we discussed with the local government to couple this flood mitigation reservoir with our managed aquifer recharge system. So this reservoir has two objectives. One is to mitigate flood disaster. The second one is secure the water resources for the future purposes. Actually, in 2010, after the heavy rain, we monitored how much of water infiltrates through this reservoir. About 2.5 million cubic meters of water infiltrate through this facility, and which means we has more water resources of 2.5 million cubic meters for the future needs. When you design the managed aquifer recharge system, you need to know the hydrogeological property of that site. Here is another part of Hancheon stream, a little bit downstream from the weir. And you can see there is no soil deposit around here. So this is the rock made from the lava flows. And you can see also another rocks over there down. That's another, that's a rock made from the different lava flows. It means there has a time difference between these two rocks. So, and between the lava eruption events, there is a boundary, and normally between the boundaries there is permeable structures like a clinker and lava tubes and other some joints. So when the water goes into the geological materials, it flows through the permeable structures. So when the water flows like this, permeable structures horizontally, and sometimes it infiltrates to the vertical through joint like this, and find out another permeable layer, and it flows in horizontally. So in that way, the infiltrate groundwater migrate horizontal, vertical, horizontal, vertical, and finally encounter the groundwater body the deep from the surface. About 150 meters from the surface, you can find the groundwater, top of the groundwater body. It means it has a very thick unsaturated zone around here. And it means that the thick unsaturated zone act as a natural geological filter system. So we use this kind of geological features to design the managed aquifer recharge system. Okay, this is today's last part. This is the injection well I mentioned before, and there are basically two methods to recharge the water. One is the infiltration basin like this, and the other is injection well like this. So this well has the 300 millimeters diameter and 40 meters depth from the surface here. In 2010, we monitored the water level changes, down gradients. There is several observation well, and we detected the recharge well arrived at that site. Also, we checked the isotope changes, and also that the isotope changes reveals that the recharged water migrate to that direction. According to the numerical simulations, the recharged water here takes time about 5 years to get the coastal area. Normally, through the stream, the water disappears in a day to the ocean. So it means we store more water by injecting here for 5 years for the future use. So, okay, this is the end to wrap up. So today we look at the geological, meteorological features at the stream, and I show you the reservoir system and infiltration system, and I also show you what types of factors to be considered when we design this kind of artificial recharge system, and why we make this kind of system. So to wrap up, the take-home message is this kind of managed aquifer recharge system can be applied to your site when you design that system is suitable for your specific site features. Okay, thank you very much for listening today.